The door is closed. I'm pleasantly surprised to see this many people here on the last day. I was expecting something different, actually, but this is great. So I'm going to talk to you guys about building blocks to get towards zero trust for APIs. We've heard a lot about zero trust, I'm sure, but it's also not sort of something you just buy and then you're done with it, right? We all know that too. So this pertains more to API security, and it is sort of components to get closer to a zero trust architecture for APIs. And close to what I deal with on a day-to-day basis, we're going to tie in identity a lot to this, because if we think of the historical part of protecting the perimeter, it was always a firewall. In my world, identity is sort of the new perimeter of sorts. So I am director of sales engineering at a company called Curity. We develop an IDP. I have done a lot of work around identity and authorization in the past. I mostly deal with pre-sales and those types of activities, but I also double into what we call our product market engineering team that creates code examples, and we write technical articles on various blog posts and our own website and things like that. So we have a lot of material actually that's extremely non-product specific on our website that's just educational for anything around OAuth and OpenID Connect. So let's start with defining sort of what I mean by identity and zero trust. We're going to talk about some of the pieces in this puzzle here: tokens, scopes, and claims. I'm hoping some of this is familiar already. We'll reiterate some of it. I'm going to try to explain sender-constrained tokens, because it's a huge part in securing access tokens and binding them to specific applications so that we prevent them from being reused if they're checked into GitHub or someone gets hold of it. And then we'll look at something called a phantom token pattern and talk a little bit about sort of what would be the next steps after this. So tokens. What are tokens? There are multiple different types of tokens, but in essence, a token is sort of a super convenient way to transport attribute data, attribute information about a user, an identity essentially. There's various types of tokens: access tokens, refresh tokens, ID tokens, for example. They are intended for different audiences. Like an ID token is typically intended for the client to get a better user experience. An access token is intended for the API to allow access to the API on behalf of the user. Now, why do we use tokens? Well, it's pretty bad these days to just send sort of your username and password directly to the API and then let the API give you access. So instead, we kind of have this protocol, OAuth, to securely authenticate a user and issue a token to that user, and then the user can use this token as its password replacement. But tokens can also hold a lot of other information, and this is parts that we can use for enforcing zero trust on APIs. Tokens are issued differently, so it depends a little bit on the application. So when an application initiates a flow to obtain a token, it will also tell the authorization server, which is the entity that issues tokens, what scopes it wants, typically. One scope is a standard scope, it's OpenID. That will then trigger the authorization server to issue an ID token as well. But there could be a bunch of other scopes. So if the application knows that it needs to talk to a transactions API or order API, it would probably request the order scope or the transaction scope, for example. That's great, but there are some caveats here. Has anybody heard about role explosion? When we dealt with like roles, right? So I've seen organizations that have many, many, many more roles than actual users, because you can end up getting into these corner cases. So you create variants of all the roles everywhere. The same could happen with scopes. There's a term, scope explosion. So next slide, we'll talk about how we can alleviate some of that. Last point here, though, there is also different tokens in the sense that we deal with JOTs, JSON Web Tokens. Everybody's heard about JOTs? Yeah? I went to a conference recently, and it was like 2 people in the room that had ever heard about JOTs, so I got a little bit concerned. But someone came up after and said, what I took out of that session was I don't know how to pronounce JOTs. So that was that was great. So JSON Web Tokens is very common. They're easy to consume. They kind of are self-contained because they don't need to be verified with a central source, right? So you can see within the token if it has expired or not. So when you validate a JOT, yeah, it's great. The problem with JOTs is that they can tend to hold too much information because they do hold a bunch of information. So we could run the risk of having PII information in the JOT. And a JOT in itself is actually not secure in the way that nobody can read the information. Then we have to encrypt it, and that's a different rabbit hole entirely. They look kind of secret, but you can just decode it and see all the information in it. Opaque tokens is different from anyone that issues them because it's typically not standardized how these tokens what they need to look like. Opaque tokens is typically just a string, like a GUID or something like that. It needs to be unique. And it means nothing to the application that holds it, right? You can send it to the API, and the API then has to introspect the opaque token with the authorization server. It's getting the token, and it's kind of like, yeah, let me check if this token is valid. And in the introspection response, it will get sort of, is it valid? It will get a bunch of information back, scopes, issuer, audience, etc. All those things that are in that introspection response and that are also in the JOT are typically called claims. So scope explosion. We can actually alleviate scope explosion somewhat by leveraging claims instead. Claims are much more dynamic. Scopes is just like a string. It doesn't really, it's not complicated at all. It's a static string. Claims, on the other hand, is something that's in the token, and the value of the claim can be extremely dynamic. You can have the same claim in separate tokens issued to separate applications, but they hold different values because the authorization server decides what value it should map to the claim. Claims are also asserted values. So if you see a claim in a token that's issued by Curity, it essentially could mean Curity asserts that Alice is a teller in California. If there's a claim that's called role, and the value of that claim is teller, and her region is California. So we can kind of like trust the information in these. This is important much later in this presentation, and I'll point it out. We can use the claims in APIs to control access to the API. And claims are great for getting deeper down into the authorization of what information the API can release. Scopes can be viewed as more coarse-grained authorization. You probably have an API gateway in front of the API that checks if the token has expired, if it's the correct issuer, if it's the correct audience, and if it has the correct scopes. After that, the API gateway kind of moves forward to the API, and it gets deeper, and that's when you do a more finer-grained authorization of specifically the data that can be released. Here's an example of a token. So it's an example of a payload of the decoded JOT too. So when I say token, this is the information you would get back if you introspect an opaque token. This is also the information that would be inside of a JOT somewhere. It's not a complete JOT because it doesn't have a header and a signature here, but. And some of these claims here are standard claims, right? Issuer, audience, not before, expiration, for example, are all default scopes that will always be in there. And those are things that should always be checked. Obviously, you shouldn't accept a token that has expired. So there's a lot of best practices around what and how to check these claims. I'm not going to go into details on that, but there's tons of libraries out there that will do all of this for you. You basically pass a token and it will just check all of these things for you. So we talked about claims, we talked about scopes. Back to scopes. In some regard, scopes are groupings of claims because you typically map claims to scopes. So if I request a specific scope, that leads to a set of claims typically being populated into the token. And that's something that you define on the authorization server side, like how should that mapping be? So it's a way of gaining several claims into the token. Who knows about mutual TLS? Fair amount. Who knows about TLS? More. Wow. That's great. So in order to talk about mutual TLS, this is going to lead up to something. I'm not going to okay, mutual TLS is great, but that in its own is not what I'm trying to get to here. I'm trying to get to what's called sender constraint tokens or proof of possession tokens, but part of that needs TLS and mutual TLS explained. So TLS is, well, it's not the new name of SSL, but most people know about SSL. It's a way for a client to verify that it's talking to the correct server. So it's a one-way authentication. The client can authenticate that I'm actually talking to the correct server. So when you go to your bank's website, you'll see that little padlock in the browser. That means TLS is enabled and that the client, your browser, has verified that you're talking to the correct website. So you're not talking to like a rogue website that's pretending to be Bank of America or something. Mutual TLS, just like it sounds, authenticates both ways. But when you're using your bank's website, you can't really do this because it's hard for the bank to be checking each and every of their customers' clients. However, in server-to-server communication, this is obviously something that can be set up. So here, both the server and the client authenticates against each other so that they do actually know that they're talking to a legitimate client. This can be leveraged to implement sender constraint tokens, or also known as proof of possession tokens. So in the traditional sense, we have bearer tokens. So those JOTs and opaque tokens that I talked about that we use as access tokens to gain access to APIs are typically referred to as bearer tokens. Proof of possession tokens are similar, but what we do is we inject like key information into the token itself, typically like a certificate thumbprint into the token. What this does is it binds the token to the client. And we can do this because the server authenticated the client through mutual TLS, so we know the client that we're talking to. So in a normal approach with regular bearer tokens, you have a client, the client obtains, in this case, client 1, let's say. It obtains a token. If that token gets lost, stolen, and client 2 grabs it and uses it to access an API, there's no check that the token belonged to client 1. So there's like, the risk here is that you lose the token. Now, that's a way less risk than losing a static API key, for example. So even with using tokens, you're sort of better off than static API keys to begin with. There's mechanisms to protect the token from being lost or stolen. I talked a little bit about that yesterday, especially around sort of single-page applications. But there's nothing binding it. Typically, tokens are fairly short-lived, or access tokens at least are fairly short-lived, or should be short-lived. They're not always, but there is a problem here. The token can be moved. You can move it to like Postman, for example, and start using it to send off requests to the API, right? Sender-constrained tokens gets bound to the client. So when the token gets issued to client 1 in this case, if it gets stolen and moved to client 2 or somewhere else, that client's not going to have the same certificate. So you can't use it. The server will actually deny this because the server validates the thumbprint in the token against the certificate in the mutual TLS communication between the client and the server. So here's another view of this. The client obtains a token from the authorization server. It uses the mutual TLS certificates there to put a thumbprint into the token, and the client the token is now bound to the client that also has a mutual TLS tunnel with the API gateway in this case that checks that the thumbprint matches the client's. This is not sort of super trivial to set up. It's also not extremely complicated to set up, so it brings a lot of value into the overall architecture, especially when it comes to like safeguarding the token in itself. There's a bunch of things that needs to be done for like financial grade deployments around sort of how this happens. How is the token issued? There's a lot of tools to use there to protect the request and response approach for how the token is actually issued and obtained by the client too. That's a whole separate talk, actually. So we talked about opaque tokens and JOTs. And JOTs are great because you don't have to constantly like verify them, right? But then I said JOTs are not that great because they hold a bunch of information and you run the risk of leaking data and information and PII information potentially. There's other downsides with JOTs too, in that if a developer on the client side see that it's getting JOTs, you know for sure that they're going to start using the JOT and they're going to start using a bunch of claims in the JOT, and all of a sudden if you change the JOT, the app will break. So there's other downsides of just relying on JOTs. I'm not saying that you should never. There's definitely use cases where you should issue JOTs as access tokens, but if you don't have to, don't do it. But we can combine this into sort of a best of both world approach. We have dubbed it the phantom token pattern. But essentially what we do is initially we issue an opaque token to this public client that we could be concerned could leak PII information, for example. So the client here only has an opaque access token. It could have an ID token, so that the client here could have a bunch of information about the identity of the user and things of that nature. But remember, the access token is intended typically for the API. So the client doesn't really need this to be a JOT. It actually doesn't really need to see any of the information in that because it's not intended for the client. So we got an opaque token in the client. It will request information from an API and passes the opaque token in the authorization header. In this case, there's an API gateway there. It doesn't have to be, but it's extremely common. Obviously, it's sort of de facto standard these days that you need something in front of the APIs. What we can do here in the API gateways, we can introspect the opaque token. And the token example that I showed before is a typical introspection response. It's a JSON payload that you get back when you introspect the token. But you can also, in the introspection call, at least to Curity, I don't know how many other IDPs that do it. There's some, for sure. You can also pass an application JOT header. So then instead of the response back from the introspection call being JSON, you actually get a signed JOT back. And now we're back to the beginning a little bit around the claims that are asserted by the issuer, which in this case is the authorization server up here, the token servers. Now the API gateway has a signed JOT instead of JSON. It can then pass that on to the API. Now, all of a sudden, the API can actually trust the information in this, right? Because it's signed. We know it didn't get tampered with along the way because that's the purpose of the JOT. We're also on the inside of sort of the API gateway, right? So we are fairly sure that nobody's going to take the token from in here. We're inside of our network. If the API needs to call another API, well, then we also pass on a signed JOT. Now, there's a whole lot of ifs in that situation, too. Should the API just use this token to access other APIs? Probably not. It should probably get hold of its own token. It might need to do some kind of token exchange or whatever. There's a lot that could go on in there. Point being, though, we do get an opaque token, which is better, safer in the public part, and we operate with a JOT on the inside. We could also have the gateway look at the expiration of the token when it gets the response and cache it accordingly. So we can have a cache where the opaque token is the key, and we have the JOT cached in the API gateway. So it doesn't have to do this whole introspection every time it gets a call until, obviously, the token is expired. Too far. So we've now talked about a couple of these sort of puzzles in the overall access control. We have the identity management system that is one layer of controlling access, or one layer of authorization, right? Because you request different scopes, it's going to behave differently. There's some level of authorization already starting there. We have the API management system that does sort of coarse-grained checks on scope, and it can handle this phantom token flow. It's going to do other things too, obviously, like rate limiting and a bunch of those things. The last piece in sort of the layered approach to authorization and to actually enforce zero trust on APIs would be something like an entitlement management system. Does anybody know what an entitlement management system is? Like Open Policy Agent or XACML PDP, or there's a lot of them now. There used to be much fewer. The entitlement management system typically has a bunch of components. This is not a talk about entitlement management systems, but there's the notion of a policy administration point where you define and author policies. The more important part is the policy decision point, or PDP. That is the decision engine. It holds the policy. It gets requests from clients. It applies the request to the policy and responds with some kind of decision, permit, deny, or other type of information that denotes what the decision is. Policy information point is something that the PDP can query at runtime or what have you to get additional information to make the decision. Policy enforcement point is the entity that enforces the decision. In what I'm talking about when it comes to APIs, that is traditionally and typically the API gateway. There's a bunch of these out on the market. There were a bunch of boots with vendors of these solutions. A flow of this could look something like this. So we have a client here up in the top left corner. Securities here, it's issuing a token. It's going to talk to some kind of API or back-end system, and here it's performing a get to a records API. So now we've gone through this sort of, we got an opaque token, we passed the opaque token. This can then introspect it, get a JOT, which is not like pictured here. But in order to do finer-grained authorization here, what we can do is we can pass on the JOT to this PDP, whichever flavor it is. And remember, again, the JOT is asserted information. A token is a great way to transport attributes, typically user attributes. This PDP here down here now might need to look up some additional information from its information points that we looked at in the previous slide. The JOT could almost be you can view it almost as a policy information point. So now we have user asserted information that an external authorization engine can make decisions on in order to provide a decision for access to this API here, the records API. And what could happen in the API gateway here is like we did a get on records. That means I want to get all the records, right? From what I can tell of this, it looks like this PDP here said, yeah, no, you can't get access to all the records based on my policy and based on the JOT that I got and based on all the other information. You can only get access to records where the user is Alice and the department is sales. Policy in place is probably something like you can only access records that you own and that are in your department. And so we had a function here on the gateway that rewrote the query based on the decision response here. So, in conclusion, a zero trust architecture maps extremely well to a token-based architecture. We should never trust and always verify. And in order to do that, we actually need to know who the user is. So there needs to be authentication, and the authentication protocols are pretty mature when it comes to OAuth and OpenID Connect, and we can leverage the tokens to pass the user attributes, asserted user attributes around. With this, identity is somewhat of a new perimeter. You need to get to that identity before you can do anything in terms of zero trust, right? Claims are great for authorization. They're great for like baseline authorization. If you need to get to finer grained authorization, especially where you have like relationship policies, like I can only access records in my own department and things like that, you probably want to start externalizing that to some entitlement management systems. We want to prevent PII information from public clients, and we can do this by sort of default mode is to issue opaque tokens instead of JOTs. There are, like I said, there are cases where you need to issue JOTs too. And approach it from a multi-layered authorization perspective. So we have the IDP is a form of authorization level. What scopes do you get? What claims do you get? You get that token. The next level is the API gateway that performs like a coarser grained, should I even call the API? There's no point if the token has expired, right? That's one level of authorization, and then you get deeper to the relational aspects of that an external PDP engine needs to take care of. And that was that. We have 2 minutes left, I think, if there's any questions. I do have a flight to catch, so I don't have a lot of time. Thank you.